many of the things that up until recently were hypotheticals in terms of climate damages, if you've been following the news, we now know are pretty extensively that no, we're no longer in hypothetical possibilities. Like we're actually getting a bunch of damages. And so, after kind of let's say a bit of a hiatus, maybe it was because of the Pacific Decadal Oscillation, maybe not, who knows, for a decade or so there, we hadn't really hit too many new record temperatures and it was kind of up in the air about what was going to happen. But at this point, if we're looking forward into 2020s as a planet and thinking about basic things like global public health, it's very clear that we have to think about the way that the climate affects this. So the climate damages are here. The second kind of key part of the talk, and that to a certain extent, I think explains why I'm an economist up here talking about this, is that when we estimate a lot of these damages, it turns out that applying techniques that are more from the modern data sciences is actually quite key, because a lot of the things that we need to do to be able to figure out exactly what's going on turn out to involve us doing things like being able to come up with a reasonable model of how the world itself works, what goes on with economies. A classic thing like this would be a drought causes crops to fail, right? The crops fail, so people are poor and don't have food. People respond, right? We don't just like sit there and say like, oh no, like my life is over. So there's some kind of aspect of this production process that ends up popping up. And so I'll try to give you a bunch of examples from the specific area of econ that I tend to work in, which is impacts of the climate on human systems. And then I'll end hopefully with a kind of a lesson and a bit of hope on this, because a lot of times this stuff is some of the most dismal, I think two of my colleagues over here from USF, some of the most dismal stuff to present on, which is definitely my reputation. And so I'm going to try to kind of in particular point out that while studying these things is dark, understanding them better means that we can predict them. And I'll give you some very, very clear examples of what this means for global climate policy, using a specific example of the current El-Niño, right? So I started doing this work about 20 years ago. There were a couple of record hot temperatures around the 2000s up through 2005 or so. And then we had about a decade where it looked like climate change might be getting worse. Who knows? Like definitely from the physical system. There's a bunch of stuff, if you follow this in the physical attribution literature. And then we started to get a bunch of what I would say are the very unequivocal signals. Right. So like every year we have the big climate agencies get together and they crunch the numbers. They say, okay, this is the average temperature for the globe this year. Right. And when you do something like break an average temperature for the planet, that's signaling that something unusual is happening. That shouldn't happen too often. So we broke the record in 2014 and then we broke it again in 2015 and then we broke it again in 2016. Right. So like 3 years, that's kind of, it's kind of like if you run into the most amazing, richest person you've ever met. Like when you're walking down the street, like, wow. And then like you go to the next block and then like it's another random billionaire. And you go to the next block and it's another random billionaire. And you're like, am I in Glen Park? Like what's going on? Right. And so this is another way of saying that the signals that we've gotten from the climate system are at this point quite unequivocal. This has been one of the interesting things doing work in this area for a while. You go back about 20 years, there's all kinds of people trying to say that climate change is a hoax. Doesn't really make too much sense. At this point, we only have the occasional nutbag who makes his way to the presidency saying things like this. Right. And so what I would say with this is that, the extent to which we are now quite clearly heading into a new regime, and it's a very, very dangerous regime, is difficult to overstate. And so this is the unfun part of the talk, in the sense that the extent to which the need for large-scale decarbonization is now about a decade or two, not too late, but like very, very pressingly where we should be, is the kind of thing that is hard for us to swallow, I think. And so, one of the ways I often like to to make this clear to us is that when we put this in historical perspective, there's a lot of variability in the climate, right? Exactly how bad is what we're doing. And so if we zoom out, the graph on the left is going 2,000 years back into the past. The graph on the right is going 11,000 years back into the past. So you can actually see us coming out of that ice age, right? You can see it like right over here coming out of the ice age, nice warm emergence of human civilization. Oops, starts to get cooler again. And you can't even see it because it's happening so fast. So here I'm just going to put a little line and then trace it in red, right? So when you think about what's going on in the overall system, we've dumped so many of the carbon and similar greenhouse gases into the atmosphere that what's normally this nice smooth process is now like being jerked in entirely a different direction. And so this is to say that there are many ways of thinking about how climate variability is or is not good for us, right? Like, sure, all kinds of ancient texts tell us about the risk of droughts and floods and storms and similar. And how are things different? Well, at this point, we're now kind of moving things so quickly that nothing can respond in time, right? And so if you're in this area, you've probably seen stuff like the Vladivostok ice cores, right? So one of the big pieces of evidence we have is we can go down to Antarctica and similar places, at least while that ice is still around, right? And we can drill all the way down a couple of kilometers and we can get little bubbles of air that are from 100,000 years ago. And we can take that little bubble of air, that little snapshot, and we can analyze it chemically and be like, okay, great. So here's, the carbon dioxide concentrations and methane. And it turns out there's this cool trick you can do where you can look at isotopes of oxygen and look at which one's heavier versus lighter. And that gives you a good proxy for the temperature at the surface of the surface of the oceans. And you get stuff like this, right? So what do we see in this time series for 500,000 years of data? Well, that's the zoomed out even more version of the ice age cycles, right? Little brief periods of warmth, right? And then going back into glaciation and woolly mammoths, etc. And then warmth, right? Happens over and over. And then the last time this thing happens, we happen. And we all get together and some kind of crazy set of human things occurs and we develop language and modern civilization and iPhones. Right? And that puts us here. All which is to say, we know in our hearts that this thing is a random kind of thing. The environment changes all the time. It's like a core part of civilization. But what we're currently doing is now definitely pushing it into a very, very bad direction very quickly. Right? And so I think more or less, if you've come to my talk, you're already like, yes, we've heard about climate change before. So like, what else can we add to this thing, Professor? So the kind of the key takeaway from this is we're in the middle of this period and we are now in this transitionary sort of like manage the crisis while it evolves state. And in particular, a core part of what this means is actively now managing how the public health system at global scale responds to this thing, right? Because we know that heat stress is bad, and we know that if crops fail, like kids can starve and people's livelihoods will fall apart, and we know that these things aren't well integrated. But understanding them better, so it's not just a hypothetical thing, but something you can actually measure and then predict and then respond to, turns out to be something that is at least within the past decade or so a relatively novel thing to do. So three things I'll give to you guys, or basically I'm presenting 3-ish papers as kind of the undergird on this. All 3 of them are open source, so you can go and download them if you like. The first one, it's like a policy overview that basically makes a bunch of the points that I just made here. The kind of the key one is that a lot of the work that gets done in this domain for a variety of reasons gets done on children. This is partly because of just the pure normative reasons, like people in general care about child welfare, right? We'll respond to threats to children's health. Part of it is also that children are very well measured, right? We know when they are born, like we get all kinds of physical measurements for them as part of checking in on their health. And so what this means is we can do things like take doctors' records at scale, put them together and look for health effects, right? In ways that are not necessarily going to be as straightforward as doing for adults. Another key thing is that from an environmental science point of view, a lot of the environmental hazards have this sort of like cumulative effects on human well-being that can be difficult to disentangle. What's novel about doing work with kids is because they've only been around for a short amount of time, a lot of the statistical issues become a lot less of an issue. You get a lot more variation, and so you get much cleaner signals from specific types of problems. And then kind of the last thing is that it turns out that like thinking this way both it helps us think about the larger damage that happens to kids' health, which is, in of itself, this first order bad thing. It also opens our eyes to measuring what those damages then mean later on in life. And one of the big things that I'll show you from this literature is that we now know that relatively mild insults to health, not being fed enough when you're young, being exposed to certain toxins, et cetera, can have measurably very bad effects later on in life. And this includes things like being exposed to certain climate hazards, right? And so the one takeaway that I kind of give you guys from this is that when we think about a lot of where climate change is going, the intuition that the most vulnerable will suffer the most is a good intuition to have, but that also leads to like policy prescriptions, right? And so one of the core things that I really do like to emphasize with this, right, is that obviously this is a daunting thing, but like we have to do what we have to do. Like we have to manage humanitarian global public health policy. We can't just like let people die by the tens of millions in a decade or two because we don't have our act together. Or, I mean, obviously we can in the sense that the global system can fail, but from a moral imperative and like basic functioning of policy kind of way of approaching this, it's we really got to be on top of this. So what does that mean? So one way of thinking about what this is going to mean in the long run is by taking a look at the most recent IPCC, whose job it is to tell us what this thing is going to mean in the medium to long run, right? The Intergovernmental Panel on Climate Change is, the UN data clearinghouse for all of climate science and climate policy and similar, right? And so when we look at a lot of what we're supposed to be thinking about in the near term, we're basically saying, if we do a really, really good job, right, pass the Green New Deal or some kind of equivalent thing, like keep pushing solar, et cetera, we should be able to peak in carbon emissions somewhere in 2040, 2050, and then bring it back down, right? And so what does this mean in terms of thinking about this larger suite of possible impacts? So the core thing that I kind of want to get across to everyone, which I'm sure a bunch of you are already internalized quite well, is that we've already baked a lot of warming into the system, right? We're currently trying to limit ourselves to 1.5 degrees C average warming for the planet, which is going to require a lot of push. And at this point does not seem feasible per se, right? We just had, as of this past year, a couple of months ago, they've calculated the nationally determined contributions that are part of the Paris Agreement. And we're just maybe, according to the climate models, now aiming the climate system towards less than 2 degrees C warming, which is good. We're moving in the right direction, but this is still kind of who knows exactly where the dice are going to land kind of thing. And that's assuming that there isn't some kind of big nonlinearity in the system. But when you look across a variety of these threats, you see there's really large gradients between 1.5 and 2, depending on where we are and what we're thinking about, right? And in context after context after context, right, the difference between 1.5 and 2 is potentially the difference between systems that make themselves work kind of, that, we can stretch to get by, we'll have enough calories, we're not getting like killing level wet bulb temperatures and that sort of thing, right? Or potentially, like we push things a little bit too far, things are a little bit more nonlinear than we think, and we start losing things like the Amazon. One of the kind of key aspects in terms of thinking about this from a more sciences sort of perspective is that what this actually means in context after context after context is quite different, right? If you are in these small island systems, or you're in North America or Europe, or you're in Australia, or wherever you are, right, there's a variety of different things that we can expect, right? They are generally destabilizing, right? But so, for example, a classic thing that we now see is that the American West is drying out. And so a whole bunch of the forest fire activity that used to be modestly well-regulated is now completely out of control, right? That's a local California thing. Do we have it in other parts of the world? Sure. Is this the same kind of thing that's threatening like Punjab or something? No, right? And so when we think about a lot of what it means to actually take this mega scale sort of understanding that the system is getting worse and the impacts are worsening and translate it into something that we could use to make society better off, a lot of ends up looking something like this, right? We'll say to ourselves, okay, so here's a bunch of the data on hurricanes. We definitely know hurricanes are bad, right? Hurricanes, definitely bad. How bad are they? Like, what does this mean? Like, how should we think about how we respond to them? Can we do a better job of dealing with them? And so to kind of make the case that econ ends up being useful for this sort of thing, right? So in essence, we're taking something like this. We're going to say something like, okay, this kind of reduces to something like this. This is our first order. Oftentimes, we first approach thinking about a system. We'll say, all right, so this is where the hurricanes are. Let's think of what's going on, right? And in a sort of simple way of thinking about this, you might say, okay, great. So like parts of southern Florida get hurt worse than central Florida, maybe some parts of coastal Georgia, et cetera, right? And if we just look through average differences here, what are we going to be conflated with? Like absolutely everything else that's gone with all of American history that has made like South Florida different from Central Florida, or that has made Savannah different from the rest of coastal Georgia or similar, right? And so this can sound like a relatively mundane sort of thing, but it points to the fact that we have to be very careful about how we estimate these things because they are correlated with other things in complex ways. Right. And so if you're over in tech and you do A/B testing, or if you're over in the biological sciences and you do randomized control trials, or just what we would normally call an experiment, right, depending on where you are in the sciences, this is something that you understand. You're like, yeah, you can't just kind of like look at the system and be like, yeah, I think I know what's going on, because maybe it's something like this, or maybe it's something like this. Right. And maybe your grand study of what's going on with American hurricanes in this model is biased by like the sociology of the coastal South. And in this one is conflated with like immigration patterns in the central high West and what that means about modern society. And so this can sound kind of academic, but it turns out that when you do a lot of this stuff, this is like with students, this is first and foremost the kind of thing that we hit all the time. And so to make the case, there's all when I teach econometrics, I do a lot of this kind of stuff where it's like, let's really keep in mind that just because two things look like they're correlated doesn't mean you've got the whole story, right? So one of my favorite examples of this is this is the North American continent, approximately like 120, 200 million, whatever it is years ago, on the order of hundreds of millions of years, right? Bunch of coastal North America, swampland, does what swampland does at the time scale of tens of millions of years, which is turn into petrochemicals and what else? Rich soils, right? The kind of rich alluvial soils that then do things like make cotton production great, which is cotton's a completely politically neutral crop, guys, right? Like it's not like cotton has like a difficult world history or anything like this, right? Especially not in the southern United States, right? So like suitability for cotton, which is ultimately related to like soil deposition from hundreds of millions of years ago, then gives you where the cotton goes, which then gives you the place that have comparative advantage in enslaving people, which then gives you things like visible patterns of voting in the 2016 election where like people are African-American versus not. And so, right, the point here is to say like you're the sociologist's intuition that things are complex, the anthropologist's intuition that it is not necessarily what it seems is it's first order true. And it's first order true even when you're over in what seems like a physical system like the climate. Right? So to make the case that, econometrics does a good job of dealing with this. And when I say econometrics, I just mean the statistics that economists do, right? Kind of a classic way of thinking about this. Again, something that I have cribbed from my own econometrics classes, right? Would be something like this. Let's say I want to design some research to figure out the effect of pollution on health. So I, as a modestly informed social researcher, look around and I say, hey, wait a second. Do you know poorer and more marginalized people tend to be less healthy? They tend to be oppressed. They then tend to live in the bad parts of town, which are then polluted. Like I read the environmental justice literature. This is true. So what this means, right, is that in formal parlance, right, we would say that health, pollution, and poverty are endogenous, right? Endogenous, they come from within the system. They all arrive together, right? Or they co-evolve. There's reverse causality. They're correlated, but it's complicated, right? Whatever kind of version of that. Right. And so what this means is that just if you look at the correlation between these things, you don't get the pure, you might think, oh, this is what I'm measuring. I'm measuring this correlation between pollution and health. Okay, yeah. But unfortunately, in the human system, these things are all convolved together. And what this means is we'll see some kind of correlation, but is it the pollution or is it the fact that there was redlining? Or is it the fact that there was like this historical immigration movement that led to a whole bunch of people that are now just correspondingly older, but also more Northern European in this part of the town and XYZ, blah, blah, blah. Or maybe it's just because we're in the middle of a recession and something else is going on in your data. Who knows? Right. And so the point is that it ends up being difficult to measure this. And, I think what's funny about this is the intuition on this, I think sometimes is, okay, so like economists say you should be careful with this, because like, oh, it's not that big of a deal or something. And it feels like this kind of like, we should do our accounting right. And it turns out with a bunch of this stuff, and I lead with air pollution for a reason, doing this with air pollution revealed that it's about an order of magnitude or two worse than we thought. Huge costs to health from air pollution, a bunch of which has come out of this weird econ public health-ish literature. How do we do it? With stuff like this, right? So one of the nice papers in this area, about 10 years old now, is like, okay, so this is a normally endogenous relationship. Let's find a situation where one part of this endogenous relationship changed like it was an experiment. Like randomly, like if I had a lab and I was able to magically just kind of like reduce pollution and see how much better off people were, right? In this case, this is what we in econ would call a natural experiment, right? People basically said, hey, look, so when the easy passes get put in, like fast track, right, on a highway system, you put that in, the number one thing that does to air pollution is it causes it to drop around the toll booths because people stop idling. You normally have a whole bunch of cars idling, which is super high pollution creation. And you get these big, dense clouds of pollutant at the toll booths. So it turns out that this very simple administrative type turnover thing that's more or less unrelated to everything else going on in people's lives, certainly unrelated to like whether or not someone who lives next to it is planning to have a kid, right? All of a sudden, you're like doing your normal life cycle, not even that aware of air pollution damages per se, right? It's not like we're all nerds up here, right? And so what do you end up happening? Well, you get this random variation, so you can put these things together, right? And then in econ, this would be called an identification strategy. It is at this point a bit dated, but if you guys remember the book Freakonomics from the 90s, Freakonomics is basically, do you know what identification strategy is? Cool, let's write a book. It's like, oh, look, it turns out like random variation can be used to understand things. It's in essence an application of this.
So that is to say, we have this endogenous relationship between poverty, health, and pollution. We find ways for things to vary exogenously through natural experiments or otherwise. And this allows us to say, no, this is the effect, right? The easy pass is opening. That was random socially, and we can check it. So the only thing that's really doing locally to someone's health should be operating through this obvious air pollution channel. And so what do we find? About a 10% reduction in low birth weight or premature birth rate. That's a big drop just from switching over toll booths. Right. So air pollution has these huge, huge effects. I'll show you a paper in a second that estimates approximately a quarter of all infant mortality in sub-Saharan Africa is due to air pollution. But so by thinking like this, and this is kind of, I'd say, if there is one methodological lesson to kind of point out here, is that there's a lot of very, very interesting work being done in this domain recently, where people are saying, hey, let's take this kind of theoretical concept seriously and try and go measure it. Oh, wow, it's way worse than we thought. And I'd say a lot of what's happened in the past 10, 20 years in the domain of environment and econ has really, there's plenty of cases where that's not the case, but a lot where it's bad. And so the intuition is, in essence, we're thinking about trying to do something like an RCT, like a randomized control trial. And so this allows us to take something like our standard A/B testing from tech, right? Or just treatment and control, but randomly assigned. The randomness allows us to ensure that the two potential treatment groups, treatment and control, look more or less identical before we actually apply the treatment, right? We take the same kind of logic, we bring it over to the environment, we do stuff like this. Right, so this is a paper of mine from about 10 years ago. We, in essence, are asking ourselves that hurricane question, saying, how bad are hurricanes for societies? We know that they destroy a lot of things. We know that they have a dynamic cost to societies, but all we ever see are these crosstabs of like how many people died and insured damages. So how do we do it? I said, well, okay, so first thing is let's accurately measure these cyclones, right? So we have these really, really great tracks data from meteorological agencies. They go back and give us locations of tropical cyclones, how intense they were, et cetera. That then lets you do things like recreate our best estimate of how bad the wind field was. We can model the approximate shape of the storm and just pass it over the map of the planet. Here I'm showing you the Philippines because the Philippines gets hit a ton. Philippines gets hit a ton and has a bunch of really high quality data. So now that treatment control type way of approaching things, in this case, becomes one where we're looking at the historical record and comparing counterfactual records in different places at different times that were or were not randomly hit by storms at certain points. You can then look within a place over time, right? In this paper, we end up looking at both econ side and health side, right? And we can look at the dynamic response. And this is why we did the paper. Turns out that about 15 times as many people die in the Philippines from cyclone hits as we think. It's just they're mostly infants, and it's mostly due to the poverty that the storms cause. We can track all the poverty, we can track income fall, we can track the expenditure fall. The expenditure is in high-calorie foods where you would think. The effects are worse in families with more kids. It's actually almost all concentrated in the girls. This is unusual. The Philippines does not have really strong sun bias, right? And this is partly, long story short, because it looks like a bunch of the boys get lost in the in utero period. All kinds of complex stuff that involves knowing something about the biological side, something about the econ design side, etc. So if we have a view that, hey, actually the tropical cyclones are about an order of magnitude worse than we thought, then maybe we reorganize how we deal with them, right? So one of the things that's been interesting in this sort of grand suite of things is the Philippines, between when we started doing this paper and now, has completely, for their own very good reasons, really revamped their disaster response, right? Because the costs are huge and the returns to doing it are enormous. So this literature is large. There's a whole bunch of stuff that you can go and find out here. Here's two nice citations if you want to go get your hands a little bit dirty in the academic literature. And so a lot of the work has been, in all kinds of different domains. We now know, for example, that there is an optimal climate for production. It's approximately room temperature. Surprise, surprise, right? We've learned that, for example, one of the things I like to emphasize with this, I mentioned before that we can show that damages to kids' health are bad enough that they persist later on in life. One of my favorite papers in this area is a little over, I guess, 13 years. Look at this, Machini and Yang from 2009. What they do is they take adult women's data in Indonesia and they look at this is height in the upper left, and then self-reported health, and then years of schooling, and then asset index, like a measure of wealth. And what you see on the bottom x-axis there is rainfall during their first year of life in their village, right? in most of Indonesia, rain just goes linearly into rice yields. The more it rains, the more rice you get. The better the rains are, the happier and fatter all the babies are. Right? Don't find this with the boys, or don't find this with the men. You find this with the women. Right? Another classic way of thinking about the fact that you need to think about the econ side of this, because the household responds and the household is favoring the sons and making sure that they get fed, then you're going to see worse damages on the female side. Right? And so this is something we pick up in adult women in their 30s and 40s. Right? Or I mentioned that air pollution and mortality in sub-Saharan Africa, or just in general Africa, although most of the data are sub-Saharan, right? Here they basically put together really detailed, really high quality air pollution data. This is Marshall Burke, who is down at Stanford. And so the kicker on this, most of the air pollution that we see that causes damage to human health at scale on the planet these days is industrial pollution, combustion, et cetera. A lot of what's interesting about this sub-Saharan African case is a lot of it is natural. And it turns out that a bunch of dust from the Sahel and from the Sahara is actually really, really bad for your health. It's like the same kind of small scale, like, PM 2.5 silica stuff. So these authors, they put it together, they do the appropriate accounting. They estimate that, there we go. That's what suggests that PM 2.5 concentration above minimum exposure levels were responsible for 22% of infant deaths in our 30 study countries, and about 500,000 in 2015. And so this is, I think, when we think about, we've all had a bit of a wake up moment with COVID and the idea that maybe we should have air filtration in public spaces, right? And I think this is one of these things where we're like, okay, great. So it turns out that like these combustion vehicles and a variety of environmental issues and just general observation of the environmental health channel has large returns. And so, a bunch of what I've shown so far, a bunch of where we see the worst damages are in developing countries where people are less able to adapt, where their livelihoods are more closely tied to things like the yields from their fields and similar. But we see these damages everywhere, right? So this was earlier this year. There's a big paper that got a lot of media coverage, pointing out a general cause of all risk hospitalization, including a bunch of enteric disease and diarrhea within the United States, right? So this is one of the other things that we know is, even if you're in the cities away from the possibility of the fields failing and everything, ambient temperature causes the disease environment to change, causes other health issues to change. It's basically, I don't know if there's any microbiologists in here, but like temperature is like free energy for microbes, right? It's like time equals heat. So it's warmer and a better environment for them. They're close to the optimum and you just get way worse diarrheal environments. So to kind of give you an example of what I mean by this, so another one of these papers, again, this one is open access. This is with Rachel Baker, who has since done a lot of work on COVID-related health stuff. Here, what we do is we take a whole bunch of these kids' heights and weight data. Again, this is from basically like census type stuff, where people go, basically part of the census, you have kids under 5, we'll get their height, weight, time of birth, etc. And what we do is we geocode these, and we pair them with temperature data from sub-Saharan Africa. One of the things that's interesting about this is that this style of research, which is over in climate impact, so I'm thinking, like all this pitch that I've given you, climate, health, policy, this is also the kind of stuff that like physical anthropology was doing during the colonial era that like everyone hated, right? Like running some kind of cross-sectional geographic association between like what country you're in and how tall you are sounds very, if you know these things, it's very eugenics-y. And so part of what's interesting about this is a bunch of what we've found now is we do have these really strong, heretofore not well documented, very, very strong gradients in people's weight, right? So kids get a lot skinnier at higher temperatures. This is just the average cross-section here. Right. So we're saying that basically if you go from sort of average-ish temperature in sub-Saharan Africa to the hottest places, you lose 1 standard deviation of kids' weight for height. So that is like a serious slimming of the kid. Right. And so now the question here is how much of this is about temperature and how much of it is about all of the other bad stuff that goes with temperature? Like, I don't know, like being a target for Belgian colonization 150 years ago. Like quite seriously, but quite like in that spirit, very, very much, right? Like, you have to take these, like, if you're like, oh yeah, it's like, I think I've got this relationship by data. Oh, it was the Belgian genocide. Oh, okay. Because that's the horrible nature of the world. And so what do? We take all these kids' data, and now instead of doing the averages, we take the actual observed temperature exposures, right? And we do it at multiple time scales simultaneously, so we can separate out the specific channel effects, and we do it by different places, urban and rural. And so what we see here, right? Now, In this graph, I'm just showing you the average relationship. Here, I've now statistically identified the relative effect on a kid's weight for height as a function of temperature over the past year, already adjusting for all of the rest of the spatial and temporal averages. So I'm just pulling the randomization out just from the whether or not it was hot or not that year when that kid was interviewed, compared to other times people had been interviewed in that same place and compared to other places across time, right? So this is one of these things that you go into the statistics to kind of pull out a bit more, but long story short, you can control for average effects of space and time. And the fact that the weather varies basically randomly, conditional on where you are, right? Like, sure, like New York is going to be warmer than Toronto, but what's the exact weather going to be like on a specific day in May next year? Kind of hard to tell. It can give you some kind of an idea, but it's random enough. So here, the first thing I want to point out here, right? So this is us basically pulling out what you might think of as a damage function, right? That links changes the temperature to losses in kids' weight. Up here, we've got this for kids from our sample, right? Down here, what we've got is the same kind of graph, but instead of looking at kids' weight, what we're looking at is yields for corn, soybeans, and cotton, right? And so what we see here and what we're increasingly kind of getting at is in the rural parts of sub-Saharan Africa, kids are so close to the just basic sort of like the subsistence line that moving the calorie burden around in terms of like temperature on yields just gets directly passed through, right? Like it gets too hot for the corn to grow, gets too hot for the kid to eat, right? And so this is one of the ways of thinking about like the fingerprint of actual very serious potential losses, right? A bunch of what we're seeing coming down the climate system, and including what I'm about to show you about the La Niñas, points to large-scale yield failures, which means large-scale famine, right? And it's a non-linear type of famine, like a little bit hotter can make this completely fall apart. Now to add insult to injury, right? We check for this in the urban areas, don't find it, makes sense, cool. People aren't growing crops in the urban areas. But remember that thing that I mentioned about diarrheal and enteric diseases? Turns out that we are now pulling out very strong signals at city level all around the world where higher temperatures make people have higher rates of diarrhea and higher rates of weight loss, right? Here we see month of survey, and this is already controlling for year of survey, et cetera, right? The hotter it is, the skinnier kids show up at time of survey. No, they don't show up shorter. Oh, there's a little bit of funniness at the top end. There might be some sampling, but this is all nice and flat, right? So yeah, it's like kids show up at survey, they're the same height, but they're skinnier. There's that diarrhea result if you want to see some confirmation. So we ultimately do this in the paper. We are even able to decompose in terms of lifetime exposure. There's the cross-sectional graph that I showed you before. And so long story short, it looks like most of that cross-section is temperature's effect per se operating through all these channels. Right. And so part of this is that, like, the physical anthropologists back in the 1800s, when they're running around as part of the English crown doing horrible things, measuring stuff, right? They're all thinking like some kind of, Darwinian social explanation of things. And like, sure. But it's actually more that we're more or less the same mechanism over and over as human biology has told us. But if you starve us because the temperature is too high, then we end up skinny. So we got this kind of very nice environment as determinant sort of way of looking at this. It also resolves this older, longer set of questions from a much earlier literature. So this is looking at the specific sort of temperature channel. So what do we do with something like this? So I kind of made the case for hope, but to get there, we have to go through one more bad thing, which is to think about what happens when these things get correlated at scale. All right, so the El-Niño Southern Oscillation is basically the first type of major weather that we have on the planet after the seasonal variation that is the summer-winter change, right? What it ends up being really is that you just kind of have this seesaw type effect where a bunch of the winds that move from east to west across the equator as the globe turns, right? There's a feedback there, and they push warm water towards Indonesia. Sometimes that breaks down, and the warm water, which you see in red here, spills east against the normal flow, right? And they end up with warm water off the coast of South America. This is where we get the original El Nino name, because it would start to happen December-ish, right? And fishermen would be like, the water is warm and the fish aren't here. And it's like Christmas time. It's like, oh, like El Nino viene, right? And here we are, right? So El Nino is a hot state. La Nina is the cold state. In essence, to kind of think about what's going on here, it is this quasi-random thing that is the principal mode of variation in the tropics, right? That is to say that as the El Nino state of the Pacific Ocean changes, a whole bunch of the rest of the planet's climate is entrained, or as we would say in this literature, it is teleconnected, connected but over distance, right? And so we start having El Nino type conditions, and then all of a sudden people in California are like, oh, it's rainy, right? And people in Australia are like, oh, the corn is failing, right? And people in Kenya are like, oh, we're having bumper crops. And then a whole bunch of these things are correlated in time. So in this paper, we say, hey, look, we know that these things are bad. There's a bunch of very, very interesting stuff. Speaking of the horrors of the late 1800s, right? We know that a bunch of the absolute worst genocidal famines under the British regime were combinations where the British were going and extracting and the El Niños happened. And you would end up with basically like large scale crop failure under the extractive regime, similar to what happened with like Ireland and the potato famine. It's like the two at the same time. That's part of why we ended up with Amartya Sen telling us that famines in general don't happen in democracies. But a bunch of that original evidence is El Nino evidence, right? So we go in and we say, okay, great. Well, let's take the El Nino La Nina time series, right? Now what we're going to do is we're going to filter it through our data on the global distribution of temperature and precipitation. This allows us to see places where El Nino causes rainfall to either increase or decrease, right? So here we see, right, when the El Nino index goes up, when it's more like an El Nino, California gets more rain, which is the thing that we look like, oh, it's an El Nino, it's going to be really rainy, right? But that's for us. Meanwhile, all those rains that were going to be over in the western part of the Pacific, they're allowed over the eastern Pacific, over the warm water here. So Indonesia dries out. You end up with things like the big Indonesian forest fires of 98, which were El Nino linked because of dry forest then, right? So critically what this means is by differentiating this precipitation effect, we're then able to just directly say, okay, cool. Now look at these same kids' height and weight data, but let's just do it at aggregate scale and talk about the overall global population, right? So we take a whole bunch of these census data from the DHS. The DHS are, I always felt conflicted about this. They are funded by USAID. This is basically like the US has been helping all these different countries fund their censuses for a very long time. And they just have this nice, really big public data set that's like women and children, like 8 million kids, 10 million kids or something like that at this point. It's amazing. It's an amazing data set. It's amazing because it lets you do things like this. That is the raw distribution of children's weight for age during El Nino versus La Nina years. It moves the whole planetary distribution. La Nina years, good rains in the tropics. El Nino years, bad rains in the tropics. Here we're actually, where this is, I should note, this graph is only within the majority of places where El Nino causes the rains to go bad, right? Critical thing to point out, right, is so that would be on this graph, the green. We also check the places where El Nino makes the rains good and we get the opposite effect. So really, really tight evidence in this case that it's specifically the rainfall channel that causes the fall apart, right? So it's basically telling us, yeah, this is El Nino at this end of the thing and La Nina over here, right? As El Nino goes, as it gets more and more El Nino, kids in general in the tropics get skinnier and skinnier, unless you're in one of the places where the teleconnections are positive, in which case for you, it's flipped and the rains are getting better. So we check this in a whole bunch of different ways. Turns out to be true within decades, within continents. All right, this is a general pattern that we can pull out. To think about exactly how big something like this is, right? We're estimating that like a standard El Nino is on the order of how much of an intervention you need to do to like offset about 100 million kids worth of starvation effect. So, takeaways from this, right? The principal thing that I often say to more technical audiences is that climate risks at this point very clearly need to be integrated into public health practice and medicine. And this comes in a variety of ways. I remember a couple of years ago, before the wildfires got really bad, chatting with a colleague who was in medicine and was in practice up in Marin or something like this. And it was like, oh yeah, I do a lot of stuff on climate change and health. He's like, how does climate change affect health? And I'm like, well, for example, like the wildfires are getting a lot worse. You've got a lot of old clients in Marin at your practice, I presume. That's really, really, really bad for respiratory everything, right? Like direct link right there, right? And it turns out that this is, in general an issue, right? We've got a whole bunch of these direct risks that we know, like, yes, so we're getting more exposure to worse heat waves and all kinds of waves, right? We're getting exposed to higher risk of worse hurricanes, that sort of thing. We're also increasingly, and this is, I think, part of why we need the economists and the sociologists and everybody else to come into these fields. There's also all the indirect effects, right? Like high temperatures cause the crops to fail, which makes people poor, right? One of the tightest links that we have in this literature now is that climate change leads to large scale conflict, which is like a us system thing. It's not about the planet. It was us deciding to then fight, right? And so when we think about a lot of this, where this goes is that we need to do this integration, and we need to in particular be very aware of the fact that this is really, really different depending on where you are. If you're in California, you really care about the wildfire risk. If you are in the South, right, the southeast of the United States, you really care about the wet bulb temperature risk and the hurricanes, right? If you're in a whole bunch of the rest of the world, you're actively worried about things like just like making your yield so that you can eat, right? And so like in the US, we don't worry as much about the yields thing, but we do have all kinds of complicated relationships in temperature and health here. Right? A classic one, for example, in the environmental justice literature is that we get these urban heat island effects, right? We pave over a city, have all this blacktop and city tops and everything. And so we concentrate heat effects, and it'll be even hotter in a paved part of town, right? That in turn is very, very well predicted by being like in the bad part of town or the poor part of town or the immigrant part of town. And so a whole bunch of the environmental justice things that we then care about at scale, we need to start being much more micro targeted. Like, oh, this is a kind of a bad heat wave for those of us in the suburbs. But if you were in the city today, especially combined with the ozone prediction, right? Excuse me. And so kind of the key takeaway, and this is where I'll kind of take us out in the last 10 minutes, is that all these methods, they're way, way better than they used to. Right? This is a field where data methodology, data gathering, econometric research design, and similar have all come together to really change how we deal with this, and in ways that are sometimes comical. Like I have all of these stories from the interior of this field where like that the nonlinear graph where I showed you guys at high temperatures has caused corn just fall apart, just like all the corn plants die. The part of why that paper got as big as it was because there were a couple of these economists that were like, no. In a system like this, everybody has full information. People know that climate change is going to happen. So they've already capitalized the prices of possible future climate change into land prices for us here in Kansas, right here in 1995. And you're like, you're telling me that people in 1995 in Kansas have a good enough idea of what climate change is going to look like in the future that they're already pricing it in. And so there's no even reason for us to go measure the damages in the first place. Which is to say that, technocratic advance, by all means, knock it when it's bad, but it can take us kind of far. And to kind of make the case that this is increasingly like a now issue, I'm going to kind of talk about these El-Niños. So I just showed you that El-Niño cycle causes a lot of damage when it kicks off. One of the things that's been very unhappy about the global climate lately is that we are in a really, really, really weird part of the El-Niño cycle that we haven't seen before. All right, so here we've got, famines of biblical proportion. This is in April 2020. Right, IRC 2.1 million Kenyans face hunger due to drought. This is September 2021. So it turns out we've been in a weird La Nina, which is normally good for most of the tropics, but remember, not all. And we've been in one since 2018, 19-ish. They're normally supposed to last like a year. We don't know. We have no idea. It's terrifying. If you're at the ocean physics side of this, you're like, man, this is not a good scene. Right. And in particular, right, so here's the precept map, the teleconnections map that I showed you guys from our paper. Now let's zoom in on the little Horn of Africa, right? And so as of about a year ago, some of my buddies and I have been basically playing like match these teleconnections map up to each other and look at what's going on in the news game. And in essence, what we're now seeing is that a whole bunch of exactly where we'd expect the worst damages to be are popping up. It's like the La Nina tells us these places are getting hit by drought, and that's exactly where we see it, in the Horn of Africa, right? And so like as of a month ago, this has now been extended out to a triple La Nina, right? Which is unprecedented. And we're basically, this is now the famine early warning system. We're kind of saying like, okay, so if you've been following international, really what's going on in the Horn of Africa, like we've got like a civil war in Ethiopia. Fortunately the Kenyan elections passed. It wasn't that bad. Right. But we've had like a lot of really, really awful unrest. And in particular, a whole bunch of it really, we just put these things in a map and you're like, yeah, it's the teleconnections map. So what do we do? Right. Part of this obviously is like immediate humanitarian food aid. And if we can predict these things better, we should be better like setting things up so that we can respond. And this includes, both like, non-US Jones Act intermediated BS food aid mechanisms, by all means, if you're in that area and you know what's up, right? But we're generally like, we're a global planet. At this point, we have a pretty good idea of how a variety of these commodities flows work. And we can now just predict ex ante, especially with like new, better methods of prediction where we can see the ENSO cycle coming like a year ahead of time, right? And so not only do we need to think about embedding this in humanitarian stuff, there's increasingly calls for us to use things like the WTO to deal with this. Right? We should be able to do things like have the WTO declare a trade emergency related to upcoming El Nino state and potentially start pushing on policy from there. You know, and so there's many things that have been changing. Like I like many other people in this space, I'm really, really, really happy with the quote unquote Inflation Reduction Act that also happens to be like the biggest, best piece of climate legislation that we've gotten so far. But this stuff is kind of coming at, you know, this is the scene in the movie where we're just kind of scraping it off, right? We're like, this really should have happened like an easy 20 years ago to ease this transition, and even that would be a push, right? But so what this means is as we look towards what's coming down, you know, down the line, we start thinking about stuff that seem like science fiction, right? I haven't read it, but apparently Ministry of the Future, a very popular press book, starts with a mass death event in wet bulb temperatures, right? Basically, if you get too hot and humid above 35 degrees C effective temperature, you in essence get to scrambled egg state on human proteins and you just cook and die. And so as of a couple years ago, we're now starting to get episodes of literally kill you heat. Not just like, oh my God, it's hot, I gotta cool down. Like, you can't cool down. It's impossible. If you are in this temperature, you die. And so you can just about see them here. They're emerging in red, right? We're getting the basic idea is coastal desert. So classically, the Persian Gulf, some parts of Pakistan, some parts of Mexico, etc. Part of what's interesting about this is as this is emerging, it is a classic statistics econometrics type problem, because these are weird, rare tail events. We have unusually high humidity, unusually high heat. They tend to be short-lived, but short-lived by which I mean a couple of days, certainly enough to kill you. And so what this means is as we're thinking like, okay, cool, like integrating these systems at scale, this includes doing things like being like, okay, like flash warning this week, like possible human mass death event in this part of the world, like get our stuff together to head it off. And so the kind of, in terms of thinking about where this kind of leaves us with things to do, you know, the number one thing I always tell people at anything like this is anything you are possibly doing to advocate for and accelerate mass decarbonization is great. There are many, many ways. We can do this in politics. We can do this in culture. We can do this in private firms, government. You can do that CPUC. But I think the general idea that anything that you're doing to help get the systems to be less carbon intensive, and in particular at scale, you know, like really accepting like, no, this is about the total amount that goes in. Like I might be like arguing with my neighbor over the best way to compost, but compared to our driving, whoo, nothing compared to the driving, right? The second thing is, and I think this is again, you know, as we all kind of learn more about this, they're just generally demanding that this stuff be integrated into our lives. And it's a lot like what we already have, right? Like we start out in all these different countries, you know, as we're developing governments, you're like, oh gosh, these earthquakes happen. I guess just an act of God, right? And then after a while, it's like, yeah, but you know some stuff about this and you can help, right? Until we eventually get to the point where like we expect the government to do things like warn us about a hurricane, get things set up, et cetera. And we should be asking for the same sorts of things for wildfires, right? We should be thinking about the same sorts of stuff at scale, right, for other people on the planet. And I think that's the number one takeaway is that it increasingly looks like a bunch of the near-term problems we'll be having related to climate are large-scale correlated in time and space and will require like actual collective action, right? We've got a lot of things that could potentially fill this domain, but it's nowhere near enough. And the extent to which, for example, like it's been very frustrating to us over in climate impacts to be like, we're entering the third El-Niño. Why isn't everyone just like, all right, like focus on Horn of Africa, a couple of these spots, and except in particular, this is definitely climate change driven large scale conflict. I don't know. But regardless, I think the way to kind of pitch this is that at the end of the day, we're all, as people that have used fossil fuels and come from civilizations that use them, right? It's like first order culpable in what's happened here. Right. And the extent to which we now have a very, very clear sort of thumbprint of what's been happening at planetary scale. It's our fault. And it's specifically doing things like killing kids at scale. Kind of demands some moral action. So that's my talk. Questions? Any questions are fine. I'm also happy to take that. How do I deal with my angry uncle who says this about climate change question? Although those are less common than they used to be. I always like to start with, what do you not understand about this?
Well, that kind of is my question, Jesse, because, you know, it's so interesting, but, you know, that's a lot of charts and graphs and data and econometric speed. And so how do we take all of that and put it in a way, and it's a big question for scientists, right? How do you take the data and make it understandable to people so they want to do what you suggested at the end? And it's, you know, I know it's not a new question, right? We all kind of grapple with how to make people understand what you know so intuitively from this work you do is that this is really bad on a big scale.
Yeah, I mean, I think there's many ways of doing it. I think there's certain audiences that are very impressed with things like charts or whatever. And I think a lot of the rest of it is then just being like, yeah, so like very crudely, like this percent of this country, this many hundreds of thousands of people, et cetera, were caused by this thing. And it's because of this. And I think that's the critical thing is even in just a journalistic sense, right? Like the amount of coverage of the Horn of Africa civil conflicts that have been breaking out that is explicitly linking it to like, yeah, this is an aggregate climate shock. It's not just, and that's the thing, it's not just like, oh, my area is having a drought. It's everyone's having a drought. So all of our fallbacks are falling apart. We can't trade with our neighboring states, et cetera. And viewing that as a correlated problem, it's like a geopolitical type of problem, I think is at the end of the day, it's as simple as simply saying like, it's the climate specifically that's causing this and we have to respond, right? And I think in a similar, I would even say there's a variety of things we've seen in environment and health that are kind of like this already, where we get this first understanding of something as a possible risk, and then we get a lot better at being like, aha, lead is very bad. Like lead is bad enough that we should get rid of it even more than we already have and just completely remediate it, right? I think lead's a nice example of some of this, but lead, of course, took decades. But that's, I think that the number one thing that I think is just like being very clear on your side that the link is established and being like, okay, like the physical scientists are telling this, it is definitely the case that at this point, climate change is causing the climate system to get more extreme and it's pushing a lot of people to the brink of famine. And so this probably means in the next like 10, 20 years, we're going to be seeing some very, very bad famine-linked conflict and unrest and everything else.
Well, and I think the food aspect is interesting, right?
Yeah.
That, like, when you think about what is going to get people to pay attention?
Yeah.
Food, right?
Mhm.
People want to eat. And so how integrated that is and how impacted, I mean, even like Californians in drought, how much of U.S. food is grown in California? Prices go up. What does that mean?
And I think people get this, people have the intuition that plants will wilt when it's hot, but the like heat wave kills all the crops, like all the crop. I think that's a core part for I think a lot of people. They're like, well, we have a lot of hot places. It's like, yeah, we don't grow corn in Arizona. Like, yeah.
Really interesting.
Please.
So, some researchers have predicted that maple one of your charts shows that there's been a reduction. And I know once again, definitely fails to the conservation. So what do you think?
Of what? Well, so I think that too late in this case is not really a meaningful thing in the sense that we will continue to be here, right? Maybe we'll die individually, right? But that in the sense that we've already done enough to change the climate at scale that it's changed and we're going to persist. There's no like, it's over, we all just die, like cartoon end kind of thing, which I think is a lot of times when we think about this, we're like, oh my God, someone's talking about global apocalypse, like we're gonna have the Bugs Bunny moment. But it's really more like, and I think, and I do a lot of this stuff at different time scales. One of my favorite things is there's been a lot of apocalypses, right? There've been many instances where a person has been like, everyone and everything I know is dying. This happened like multiple times across human civilizational scale. And I think one way of putting this is like, how good are we going to get at averting a global apocalypse? And so I'd say in terms of probabilities, the extent to which we have on our side that we are very, very motivated to not die. And we're very good at tricking ourselves into doing things at scale. And so a bunch of this has changed. I mean, like when I first started doing this, like cost of solar was 50 times higher than it is today. Like general understanding, like we're moving so quickly at this point, it should have been happening 20 years ago, but we're now in this weird sort of in-between period where it's, well, technology is going to change a lot. Plus we have a lot of bad things baked into it. And to be quite frank, like I think it's going to be this, we're never going to get to this clear answer of like, is it too late? It's going to be this continual management thing, decade over decade. And hopefully we won't have to do something like dim the sky and like blot out the sun for a bit to cool things down. Right. But it's really, we are actually in the sci-fi territory where like my official answer is like high uncertainty. Please. Yeah, temperature. Yes. Let me do this guy, right? Yeah. So interestingly, my understanding of this is a bunch of what we're seeing there in that delay, that's basically the interwar period, is this combination of a bunch of the reorganization post World War II, and in particular, a big increase in human pollutants and aerosols from early industrialization. It turns out that that's part of why when we think about what geoengineering would look like, when we're like, oh, we might dim the sun, what we mean is we might put a whole bunch of sulfur dioxide up into the upper atmosphere. Part of why we know that in essence makes the planet shinier, like that gas is a little bit shinier, and so the planet reflects back a bunch more like little mirrors, and that much less radiation gets in, and so the planet is that much cooler. So a bunch of what we believe that pause is during the process of us industrializing with this big super dirty period, with it actually caused a bunch of global dimming. There's also a bunch of natural histories in there, but that's my current understanding of that. The 20-ish year pause is it's like sulfate aerosols. And so that's why people are like, they're like, yeah, if this gets completely out of control, maybe what we do is so volcanoes emit these things too, right? So volcanoes will dim the planet and make it a little bit cooler. And like one of the like mad science policy approaches, we just start setting off volcanoes every year. And we'll be like, yeah, we have like 10 mega volcanoes a year to catch up with how bad we are. So it's ridiculous. And like we kill everything else, but yeah. Hence geoengineering being mad sciencey. Yes.
So this is like, kind of, when you talk about trends, but like, you know, one of the last things I just didn't show is like, what is like more with that in like previous
Like what were global deaths like in 1850?
yeah,
Not good.
like,
Yeah.
you know, relatively, as far as like being able to identify like, you know, how significant increasing during climate impact, and obviously, you know,
Yeah, I mean, so that's kind of in the domain of when I was motivating stuff like the geography-ish related research stuff, and I was like, guys, be careful that we don't do something like this. And in essence, what you're asking is like the time series version of same. And the point is that yeah. When viewed at global scale, like the 1850s, it was like we had an infant death rate of like 1 in 3. You know, like life expectancy was like 55 if you were lucky. And so at scale, we've done a lot better. And I think this is, one of the things that it's weird. I sometimes register to people as being very left wing or very right wing, depending on what their priors are, right? By which I mean like their expectations, like what an economist is or similar. But I think it's very easy for us in 2022 to take for granted the fact that like we don't die and we have enough food and we're warm and a whole bunch of these sorts of things, which are unequivocally great, And so I'll sometimes interact with people that are very degrowthy. Like what we really got to do is like completely take apart the economy and go back to living with sticks and dirt or something. And I'm like, that's not a tenable thing for 8 billion people, my friend. And so on the one hand, we've had a lot of this progress. The problem is that this exact motivation is what then lets us go off and do a bunch of these measurements and to say, yeah. So the overall trends look like this, but the actual partial effects look like this. And I'd say that the kind of the flip side of it is we're doing way better than we used to, right? So for example, one of the papers in this general pollution-y type literature and similar, rather than pairing with pollution, they pair it with temperature. And they do this really cool thing. This is a nice example of the kind of cool stuff you can do these days with crazy huge data sets. They take census data, individual people, millions upon millions of them. They get their earnings at age 26 or age 30 or whatever it is. And they also get time and place of birth, and they're able to do temperature effects on health and latter life. And they show that high temperature had all these bad effects in the United States, but then you basically look at it, just completely fades out over the 60s, 70s, and 80s, like right when air conditioning is being rolled out. Right. And so this is one of these things, it's like it's very hip to be anti-AC. I think like, no, like, but yeah. When you need the air conditioning, you really need the air conditioning. And especially when it's like, hey, I need to like watch my health because I'm pregnant, or like I need to do my work and focus. Like you need to find ways to cool the system down. I think this is why it's at the end of the day, this weird tension between like, we need the technology. We need to be able to like get around and live our lives and eat and stuff. But like, and everyone on the planet has a right to these things. But at the same time, like we should do it without killing everyone. It's a tension. Please. Yes. Thank you.
I guess building out the first question, because I think you had such amazing technology, and it's great to see, it's over my head a little bit about tools that are available to you. But like, how do you, I don't know if you correctly, but like, how do people in the research community climate science make it applicable? Like, working with journalists, is it like building both the community, policy, all of the above?
Yeah, many things, depending on who you are and what you're doing. Yeah.
Keep it optimistic. I was just wondering if there anything like.
Well, I mean, so
You're doing in there.
part of what this whole kind of point that I'm making here about statistical attribution, part of why it's so important is that if you do this stuff well, it's very like it's a high standard. And so if you go to the business literature, or you go to that matter to people setting business policy, or you're an economist and you do macro stuff, and like the governor of your state is like open comment time on our policies, you can then be like, hey, and so this is part of what happened with the air pollution literature. Basically, like the backstory on econ is econ gets into, econ has its first bit of environmental stuff in the 70s. US starts passing a bunch of environmental laws. A bunch of more conservative business type economists are like, hey, these things are costly. We're looking at this, like you're making us do these things, like blah, blah, blah. Let's really think about the cost benefit here. And at this point, cost benefit feels like a very dirty thing for the environmental people, because it's like, oh, we're like looking at all these costs and businesses have to pay it. This is what we're doing to like have this nice clean lake. It feels kind of like a splurge aesthetic spend, right? And I think this is a lot of what's interesting about environmental policy is it still for people in older cohorts has this kind of feeling. Whereas when you now look at a bunch of what's going on, right? It's like, oh, sure, these are the business costs. But when you go over and do the health estimates on air pollution, they're so much worse than we thought that the benefits swamp them. So a whole bunch of this literature, including people like Janet Curry, who's like one of our top economists, and she's like a chief like child health economist. It's a lot of work in this area, right? A bunch of this is basically saying like, okay, business economists, let's do the cost benefit. Let's check. Oh my God, it's enormous. And so as a result, we now have a whole bunch of what's happened at national policy scale and international policy scale related to air pollution now, including things like China very aggressively pushing against the pollution drive, like as of 2014, 2015, turning around, was this literature. And people be like, wait, how bad are these things? In similar fashion, and it's interesting this way, so the climate conflict people got a lot of interest from, surprise, surprise, the military. Right. And it's kind of, that's part of what I think in general, this system has been interesting to observe is it's like, it's not always the actors that you want to think are going to be doing the thing. Like, oh, like who are like early actors on climate change? The big insurance companies, because they've got 100-year time frames where they can't lie about the physical realities of the world. And if Miami's going to be underwater, they're going to be the one who pays the bill. So they care about it. And the military, because the military is like, hey, look, we've got like decades-long planning horizons. If you're telling us that the Horn of Africa is going to be depopulated by 2055, that is something we should know about because we have to start getting ready for that. You know what I mean? So it is a weird area to be in. It's why I like it, because it has this weird like businessy bite to it, but you get to do work on these things. And so a lot of times, I mean, that is, I think, in a bunch of ways, the goal is to get the policymakers to listen to you. I mean, a bunch of my stuff ends up in the IPCC reports, right? When I'm giving all these like these things with all the various impact damages, like where am I? I'm in one of these under like, human health and damages, like, okay, cool. My stuff goes into this column, which is gratifying actually. But yes, I also do things like this and I should do more stuff like this. If it's hiding in my den running regressions all the time. How often, back before the pandemic, not that often. I've been for a couple of years, I've been doing a lot of research work specifically, and I do a lot of graduate student advising, and I'm generally busy at USF. I like it. I do enjoy it.
Talking about some companies out hiring
Yeah.
Are there kind of things that can motivate these companies that focus on short-term profits to look at decarbonization efforts?
I mean, it really depends on how we think about the funding cycle for the firms, right? In the sense that it's like, it really depends on what niche you're thinking about, what kind of investor profile over what time horizon and similar. And so I think it really on a firm by firm case is going to depend, right? Some firms like completely do not care, right? And that's one of the things that's kind of funny about being in this area of econ is like, oh, my grad students really care. It's really great. And they'll be like, you go over to like a business econ department and they'll be like, why do you care about children dying? Like, what are you doing? Why are you doing this work? Which is, I mean, like if you're a private profit seeking firm, you're just like, this isn't my domain. Like I'm here to maximize profits. So if you're a profit maximizing firm, you have to engage with people in that way. And the number one way that I think is material to say for each business case, like, does this business intend to be around for 10 years or 20 years or whatever? Like what's the actual horizon on the firm? And it, for a lot of firms, this is now a make or break important thing. Right? If you're in logistics, you really care about the distribution of temperatures because you've got people out there in the field who get exposed to sensible heat, and so depending on what you're doing, that could be a big deal. But yeah, I'd say I don't know. I'm a former investment banker. I have very strong views on people's investment horizons and how they think about like what you're supposed to do as a firm. As a general thing, I think that the extent to which a lot of the firms at this point in our ecosystem in SF like are so far removed from the physical problem that it's hard to even get through to them. But then along those lines, you can also talk with them in other ways about other logistic stuff, or for that matter, I mean, like a whole bunch of the people that I used to know in finance, in normal finance, now do like ag, fintech, climate impact related stuff, which I find fascinating. But like, there's a lot of stuff that's in this domain, and this is part of why I think this is interesting. Is on the private sector, if you know that next year there's going to be another El-Niño, you can take positions, and you like you. So, for example, like we, as soon as any risk of Ukraine conflict started looking realistic, like a whole bunch of the commodities markets started moving around, production starts shifting. It's kept it from being anywhere near as bad of a global crisis. And my general view on this is going to be much more of a like global spatio-temporal cycle that we're going to start finding ourselves in. That's like the boom bust and the climate things, where the actual coordination of response is going to have huge returns. So I was going to talk with the firm about something like that. If like you're thinking about becoming a global scale firm, like you have to think about a variety of these things. If you are some startup in SF working on some random app, like you could probably get away with just like completely ignoring it, like all the other problems that we ignore when we tech firms in SF. Questions as well? No.
Yes. I do know that big moments. I know that in public housing, lawsuits as video too. So the parking being put in.
Yeah.
One when they actually go cancel the store after they go. Right? As opposed to doing flowers.
Yeah.
Stuff like that.
Yeah.
But so I mean, I don't see the architecture really. There still be lots of fake glass and all that, which I don't know. I think eventually
I mean, I think it's so the where I'll go with this is when people talk about like, oh, the best response to climate change is degrowth. I'm like, who's going to take all of the old buildings and update the infrastructure so it works again? And then just enormous amounts of like physical works at scale that have to be done. And a bunch of it is stuff like this. It's like, are we going to continue to spend enormous amounts of energy to air condition this thing, or are we going to build a different version of this thing that's like 10 times more energy efficient and does the thing? So yeah, I'm